All right, everyone. It's 10 o'clock, so let's get started. I want to thank you all for joining me on this lovely Friday morning, maybe afternoon for some of you. But again, just thank you for taking some time out of your busy day to come and listen to my presentation. Let's get started. Today, we are talking about our MQTT data acquisition modules. So on the agenda for today, we're going to talk about what MQTT is and why that matters to you. We're going to be talking about how it works. We're going to look at an MQTT factory automation application, and then we will look at some of our MQ-7200 data acquisition modules, as well as our UA5200 IoT servers. As always, we're going to wrap this up with a live Q&A session. So if you have any questions, if you think of them during the presentation, I would ask that you please hold them to the end, or rather, instead of holding them to the end, you can type them into the Q&A box. And you can see that through your Zoom toolbar. It says Q&A. Please type them in there, and we will answer them on the air at the end. I have Steve, one of our engineers, with me today. He can answer some of your more technical questions. Excuse me. Excuse me. That's better. Right. If you would prefer to answer your question over the air, if you have a mic, you can do that at the end. Just raise your hand and we will unmute you so you can ask us live. Let's move on. So we are ICP DAS USA. Our home office, ICP DAS, was established in 1993. Their headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets, and we are located in Lomita, California. So most of our products are RoHS compliant, meaning they are lead-free. We're ISO 9001 certified here in the States, SGS certified in the UK, and we are a Microsoft Windows embedded partner. But let's jump right into it, shall we? So MQTT stands for Message Queuing Telemetry Transport. MQTT is an ISO standard application layer protocol that works over TCP/IP. It uses a publish-subscribe model to relay messages between machines with very human-readable topic hierarchies. We'll get to that in a little bit. It's lightweight, open, and simple, designed so as to be easy to implement. In fact, in the next couple minutes, I'm going to describe in more detail how the protocol works, and in giving examples of how the protocol works, I'm going to describe fairly completely from start to finish how to set up one of our MQTT I/O modules. So these characteristics make it ideal for use in many situations, including constrained environments such as M2M communication and IoT contexts where a small code footprint is required and or network bandwidth is at a premium. And just quickly, one of the reasons why I think it's important to understand MQTT is because MQTT is popular and has only gotten more popular over the last couple years. What we're looking at is a Google trend graph covering the last 5 years of search interest, comparing the search prevalence of MQTT to similar messaging protocols. So Google Trends, if you don't already know, is a Google product, and it shows changes in search volume over time, and you compare search popularity of search terms relative to the other terms. So you shouldn't take this graph as gospel, but I do think it is a good indicator that MQTT is the most popular protocol in at least this group of very widely known messaging protocols, and is the most talked about protocol on the list. And this does clearly show that its provenance compared to the others has grown consistently over the last 5 years. So how it works in a nutshell is that MQTT is a messaging protocol. It manages messages between MQTT clients and MQTT brokers or servers. Originally, they were called brokers, but now the term servers has become pretty ubiquitous, and you see them both used pretty frequently. So in a data acquisition application, both data acquisition modules and their controllers are considered MQTT clients. They both send and receive messages through the broker. This is a slightly different paradigm than what I'm used to when I think about machine communication. By way of analogy, a request-response protocol, like HTTP, is like ordering food off of a menu at a restaurant. You make a request, you want the turkey club, the request goes back to the kitchen, and they send out your sandwich as a response. MQTT works more like a TV station. The different channels, our topics in this case, are broadcasting at their regularly scheduled intervals, whether you happen to be watching or not. And you tune in to each channel depending on what you want to see. So you subscribe to each topic, kind of like tuning into a TV channel. Going into a little more detail, let's look at an example using one of our MQ-7200 DAQ modules. So this diagram shows a little more clearly the relationship between a specific module and the end user. So you have the module represented there on the left, and the end user represented by the cell phone there on the right. The MQTT clients at opposite ends of the diagram are subscribed to the same topic, and this topic is the DO status, digital output status, of one channel on the MQ-7200, and this shows the light status. So the MQ-7200 publishes the DO status to the broker at a set interval, anywhere from once every 10 seconds to once every 10 minutes, with this particular module, and the user on the other end receives the message as soon as it's published. So as long as they're subscribed to that topic, the end user is going to receive the status of that particular digital output channel. And it works both ways. The end user can publish an off command to the broker that the module will receive and change the digital output status to off. So you can see this quick little diagram just shows how that works. So this is what a configuration page looks like for an MQ-7200 module. And again, I figure the best way to teach you about the protocol is to just jump in with some examples from our products. So here on this page, you can enable and disable the MQTT conversation and use the module just like you would any other TCP/IP data acquisition module. You can see the broker's address there at the top. It communicates over port 1883 by default. Each MQTT client has a unique identifier, and you can also assign an alias here on this page. And nice thing about MQTT is that you can use aliases as topics. So if you wanted to call this module kitchen, you can subscribe to all the inputs and outputs in your kitchen to see the status of everything that's going on in the kitchen. And then you can subscribe to the inputs and outputs under kitchen. You could call the different in and out channels. You could call them kitchen overhead, kitchen floor, kitchen heater, etc. Turn lights and different devices off. And you can turn individual devices on and off using those individual topics. Alternatively, you can send a message to everything under the kitchen topic to turn it all on or all off at once. And last on this slide, I want to point out the user authentication settings there at the bottom, because I'm sure that you're wondering, with a protocol that is constantly broadcasting, how to secure your data. And the protocol provides pretty much one way to do that, which is by requiring user authentication. And that's managed through the broker. But I've mentioned topics a couple times, so let's talk about it in a little more detail. Topics and topic hierarchies. So here's what those topics actually look like on the configuration page, again, of one of the MQ-7200s. So we're looking at 8 digital output channels and how they're assigned as MQTT topics. The highest level on the left is either a default name or the alias you defined on the previous page. So if you name this module kitchen, it would say kitchen on the very left. The way our modules are set up, the middle value doesn't change. It's either going to be get value or set value. Get value is used to read status from both input and output channels, and set value is used to change output channel values. Output channels have both get value and set value topics by default. The third level on the right-hand side is the name or alias for that specific channel. So if you want to rename a channel to Overhead or Table 1, you can. You can name it anything up to 16 characters. So the MQTT topics for your kitchen lights might look like kitchen/getValue/overhead or kitchen/setValue/table1. And comparing this diagram here in the middle to the one we saw on the previous, I think, two slides ago, you can see the user, the MQTT client on the right, is subscribed to the topic for digital output channel 2, and it sends the message 0 to the broker. The broker publishes that message to the data acquisition module, and that turns the light off. All right, so let's try and put everything together. So in the configuration page for the MQ-7200 modules, there's a tab for publications, and this is what it will look like for both input and output values. This is where you make changes to the I/O channel alias on the right hand, and where you can configure your QoS and interval settings. You set a number between 10 and 600 to publish from anywhere from once every 10 seconds to once every 10 minutes, and then you choose a quality of service value. At QoS 0, the message sends at most once. At QoS 1, the message sends at least once and possibly multiple times. QoS 2 guarantees the message is sent exactly once. So QoS 0 through 2 are in ascending order of bandwidth usage. This allows you to do your own cost-benefit analysis as to how important it is to get a message to each subscriber at every interval versus how much bandwidth you have available to use. And this is just showing that publications page in a little more detail. So you have the IO type there on the left, the IO number, second from the left, and topic that is assigned, current status, and then you can change status right through the HMI on the module itself. All right, speaking of the HMI, this is what each module's web HMI looks like. This is the interface web page you will be greeted with when you navigate to a module's network address directly over your LAN. You can see the I/O status for each of your topics, and you can change the status of your output channels right from there. You can also check on your network status from here. So this is what the GUI looks like if you want to control the module directly. But for other applications, you would need to message the module through the broker. And for that, you can use a very wide range of IoT and SCADA platforms, such as our very own IoT software platform. You can use Indusoft, and the protocol is very widely implemented in both proprietary and open source platforms. So you have a lot of options for communicating with the broker. And let's look at a factory application. So in this diagram, we're assuming that a factory has 2 automation production lines located in different areas of the building. Each production line equips a counter module, which is used to count the total number of finished goods. If the total number of finished goods is changed, the module will publish the MQTT message with the total number of finished goods to the MQTT broker. The counter modules also subscribe to the stop production topic from the broker to stop the operation once you reach a certain level of finished goods. There is a WISE 5231 controller acting as the broker, which is used to subscribe the topic of the total number of finished goods for each production line from the MQTT broker. After the WISE 5231 gets the total number of finished goods and verifies that the number has reached 5,000, in this case, the WISE will publish the stop production topic to the MQTT broker, and then the production line will stop the production operation when it receives a publication through the stop production topic. So following is a diagram that explains that in a little bit more detail. And I misspoke earlier. The WISE 5231 is acting as a client, not a broker. And it's just a fairly simple operation where you have it's just a start and stop program using MQTT counter clients on both sides of the production line to communicate with one of our WISE modules. And it's using just a simple if-then statement to stop the production lines once they have reached 5,000 finished units. So let's quickly reiterate. MQTT's popularity as a messaging protocol is growing year over year. It is already a widely adopted protocol in the IoT and IIoT fields. It is designed for low bandwidth and low power consumption implementations, making it a great choice for not just home and building automation, but also for the oil and gas field or any large-scale implementation where bandwidth or network reliability is a going concern. It's easy to use. The publish-subscribe model makes it ideal for periodically monitoring the status of less than critical machines and processes at remote locations. So I hope you have a pretty good understanding of how MQTT works. Let's look at some of our DAQ modules. And like I said, the best way that I could think of to describe the protocol was to walk you through how to set up and configure one of these modules. So you've seen what they look like on the inside, and this is what they look like on the outside. And we'll take a quick look at the specs. So if you're familiar with our products, then it should come as no surprise to you that these are based on our ET7200 Modbus TCP IO modules, but these have a bit of extra juice. So these modules feature a very robust metal housing, dual Ethernet ports for easy daisy chaining, the built-in web server and MQTT settings that you saw before. Each has 8 channels of digital input and 8 channels of digital output. Depending on the model, your options for input are sync and source, dry and wet contacts, and the outputs are all isolated open collector with a max load current of 650 milliamps and 3.5 to 50 volts DC, depending on the model. And where would the MQTT clients be without a broker? So the UA5200 series is what we would recommend to use as an MQTT broker. This is a family of IoT servers that offer both an MQTT client and server function, as well as an OPC UA server. Well, one of the concerns that you run into when working with MQTT is that there's no built-in function for storing and logging data. But the UA5200 server solves that problem, and you can log data onto the module itself on an SD card. You can transmit it back to the control room and log it there, or you can upload it to cloud storage. They have lots of options. You can also schedule an FTP upload. The UA5200 family comes in plastic or metal case and a 3G versions for those truly remote applications. If you want an efficient IoT server that packs a lot of function in a very small package, you could do a lot worse than the UA5200. Now let's just take a look at the UA5200 system architecture. Just wanted to show off this diagram. It shows off what you can do with the modules at both the application and the IT layer. The server offers Ethernet and RS-485 COM ports for communication with your data acquisition modules, power meters, other sensors at the operational layer. It offers direct support with Microsoft Azure, AWS, and IBM Bluemix cloud platforms on the IT layer. The servers allow you to send email alerts in response to real-time conditions. You can schedule FTP uploads of your data logs, and you can communicate with system control architecture like HMIs and your control room through your Ethernet COM ports. So a very versatile IoT server, highly recommended. And that about brings us to the end of my presentation. I want to thank you for taking time out of your busy day to come and listen to me talk. I hope you learned something, and I hope you come back next month for my talk about some of the new IoT products that we have for you this year. In the future, I hope that you will choose ICP DAS USA for your data acquisition, industrial communication, and industrial control needs. We are committed to providing the best possible products at the best possible price. So please do think of us when you're planning your next project, no matter how big or small. With that said, I want to move into our Q&A session. As I had said at the top, we have Steve here to answer some of your more technical questions. He's from our engineering department. Following the Q&A session, I will announce the winner of this month's raffle. And then I'll let you go. But right now, the floor is yours. We will get to the unanswered questions in the Q&A box first. And then if you want to speak on mic, you can raise your hand, and I will unmute.